to talk about modern platforms and platforms that power modern apps. Biju, you are the closing act. Take it away, buddy. Thank you.
I'm not sure if I am going to be the best today because the best is after me, the food. Just by raising hands, how many of you are part of a platform team? Awesome. I think I am speaking to the choir if that is the case. For those of you who may not know enough about platforms, this could be a good learning opportunity. What we'll be doing is learning what is a platform, why do you need a platform, and if you want to implement it, how do you go about it, right? Some of you may be familiar with this diagram. We have touched a lot on it today, so I won't jump too much into the details. But what you see on your left is the situation that was there around 2010s. And talking to some of you, I heard that in 2010, some of you were in your high school, right? So you are fortunate to have missed what you see on the left, which is highly siloed organizations. We had the server team, the network team, the database team, the VM team. And if you, unfortunately, were a part of a team which had to deliver apps, deliver features, like I was a developer throughout. And Carlos, I still consider myself a developer wherever he is. What you had to do is open a ticket to the server team, open a ticket to the database team, open a ticket to the VM team. And if you touch back to one of the DORA metrics that was referred to earlier, lead time to change, basically it is from the point of a commit, when do you see that commit in production? You can imagine how much time it would have taken. Literally months. I was at Nike around 2015 timelines. And for some of their legacy products, they had a 6-month life cycle. Every 6 months, they would batch up the features together and release it. And the reason, again, is because it takes time to open tickets against the server team, the database team, and so on. We have heard a lot about DevOps today, right? What you see on your right is the ultimate form of DevOps, which is platform as a service. There were 2 products that both Rohit, that a bunch of us actually here got to be part of. Cloud Foundry. How many of you have heard of Cloud Foundry? Awesome. This is great. So Cloud Foundry is a platform as a service. What that does is it abstracts out the infrastructure, the servers, the VM, even to a certain extent, even something like a database, and provides an API where all I have to say is provide the source code for the app and say, run this app for me, right? It makes things so simple. But the platform that we are talking about is not the PaaS solution. Although PaaS solution was great, but it is not the platform that we are talking about. And I'll come to the reasons why. Consider that you today are writing an app or a service which needs a database. What all would you have to think about? And I'm going to take it in 2 different, let's call it silos. The first is development time. What all do you have to think about during development time? Simple. First is a source repository. You need some place to host your source repository. You need the build tools, something which builds your source code and creates an artifact. Once you have an artifact, you need an artifact registry to place the artifact at. You need to do some basic analysis of your code base. You need to do the dependency analysis. You need to do some level of static code analysis. And finally, once you have the artifact, once you have analyzed everything, you need to deploy it using a deploy tool, right? A Spinnaker or a Jenkins that you can think of. There is more to it. ideally, you would want a bootstrap, some snippet of your code which has the blessed dependencies of your organization in it, which has the telemetry related code base in it, traces, logs, and metrics. It needs to be secure, so maybe it needs to behave like a OAuth 2 resource server, right? And finally, it needs to keep the credentials somewhere. So you need some level of integration with a secrets manager, right? But this is all at development time. Now, once you're ready to deploy it, there are a lot more considerations. Somebody needs to provision all their infrastructure, the VMs, the servers, the database. Somebody needs to be running the infrastructure to keep your secrets, right? Could be a KMS on Google Cloud side. I'm not sure about the equivalent products on the Azure or AWS side. You need observability. Once you run your application, you need to see the metrics somewhere. So you need an observability platform. You need service-to-service connectivity. Your service doesn't live in isolation. It needs to talk to other services. So you need some level of service-to-service connectivity. Network security. Finally, the runtime. Where do you run your application? On Google side, it could be a Kubernetes environment, Cloud Run, anything that you can think of, any of the runtime environments that you can think of. And finally, you have the app. So if you look at these two slides, whatever you see in the red box are things that every service will have to do, but that is not the one providing the functionality for your product. What is providing the core functionality for your product is just the app on the very top. But you still have to take care of everything in that red box. I'm going to refer to this as the red box again later on. Imagine now a different service team having to do this entire thing. What do you think will happen? Again, I have to take the example of Nike, where this happened around 2015 timelines, where we were getting into the cloud for the first time. Every service team was trying to figure out the cloud for themselves. And what happened was every service team ended up with its own CI tool, slightly different variation of Jenkins, slightly maybe a different tool, CI tool altogether. Different way of representing the trace headers. So much so that if I were to call a different service at Nike, the trace header wouldn't propagate because they would understand the trace headers in a different way, right? So that is what would happen if every service team takes care of this entire red box. You will end up having multiples of these red boxes. It will be utter chaos. The solution is the topic, the platform engineering as a discipline. There was a survey, IDC survey done at some point, where they claimed that software engineers spend only 20% of their time working on the app, which, as you can see, is, I think it is intuitive if you look at this diagram, because 80% of the time is spent on the red box, the platform. So I think I have laid the reason for why practice like platform engineering is required. This is the formal definition from a Google's perspective, but I think it is the perspective even from the entire software industry. So platform for modern apps is the teams responsible for providing the paved paths for software engineering teams. See how I'm saying the teams. It's not it is a product that is created at the end of it, but it is the teams that you put together whose responsibility it is to create that product, right? And it's the team's job to deliver it as an internal product. What do I mean by that? What I mean by that is that there is no the platform that you can buy from anywhere. The team that you put together for the platform has to create it customized to your organization. If any vendor comes to you and sells the platform, my advice would be to run away from them, right? Because they are promising you snake oil. There is nothing like the platform. You will have to assemble the platform for your company. I'll skip this. Basically, it claims that 80% of the organizations at some point will have platform engineering organizations. And from the number of people who raised hands here, I think it should be obvious. I think we will be starting to see organizations start to adopt platform engineering practices. How is a platform engineering team organized? Just like any other DevOps team. You will have a combination of developers and operators or administrators. It's just like any other development team. Maybe in the case of platform teams, it may be a little more ops heavy. In case you need to operate a database or a Kafka cluster or a Jenkins cluster, it may be a little more operations heavy, but a typical DevOps team, their focus will be on creating that platform, that red box if you go back to the diagram that I had shared. And there will be one platform team for your organization servicing the different application teams. What are the basic principles that a platform team should have? I think it should be very obvious from what I have mentioned so far. Platform is the product that the platform team has to create, so it should have a product manager assigned to it. The product manager's responsibility is to create the backlog for the platform as a product. And at the end of it, you should aim for, just like you would aim for a minimum viable product, you should aim for a minimum viable platform in this case. And over time, iterate and improve it, essentially. Platform teams own and build the tool chain and abstractions around the complex infrastructure. Everything that you see saw in the red box, it's their responsibility. It's the platform team's responsibility. And ultimately, it should also provide end-to-end paved paths for the different application teams to use. Right? So these are the platform engineering principles. Again, just to repeat what I just said, the objective, why platform engineering matters, to reduce the cognitive load on your developers, to take the developers' focus away from that red box that you saw earlier on to delivering functionality that you see, just delivering functionality for their apps, accelerate application development, and to improve safety by baking in guardrails, right? And one example of that is if you go back to the network security. If you leave network security to apps, it's very likely that they will do whatever is simplest for their apps to function. But in that process, they may leave, say, a S3 bucket open for somebody else to access, right? So that's why it is very important to bake in guardrails as part of the platform teams itself. All right, so now that you have seen what is platform engineering, why platform engineering, how do you go about creating a platform engineering team? And here, like I mentioned, all I can suggest is the Lego pieces, right? It is up to the platform engineering team to put together those Lego pieces into a beautiful Millennium Falcon that you see here, right? The platform. And from Google Cloud's perspective, I'm going to put it into 3 different buckets. One is productivity, efficiency, and security. On the productivity side, how many of you have used cloud IDEs, right? A VS Code or a JetBrains over the cloud? Awesome, all right. JetBrains, anybody? Okay. It is actually a neat piece of technology where the core of, in the case of JetBrains, runs in the cloud, runs on a different machine altogether, and you access the core using a small facade, right? And the advantage that you get there is that you, say for example, if your build, say if there is a JavaScript-based build pipeline, which takes a long time to assemble that your artifact, you can assign a lot more CPUs or memory to that machine, remote machine, right? And if you need more, you can grab more from the cloud. Right? So that is the advantage of what Cloud IDE provides. So the couple of tools for productivity, that is the first one. Cloud IDE is cloud work. We have a product called Cloud Workstations that provides that secure Cloud IDE for you, both VS Code as well as JetBrains. I love this tool called Cloud Build. If any of you have gone through the pain of using Jenkins, installing just the right plugins, creating a pipeline, only to find that that pipeline doesn't run in a different Jenkins environment because you're missing some plugin that you require in a different environment, right? For you, Cloud Build is the solution. It's a serverless build tool. All you do is provide your build script to it. It will scale out and run your script as required, right? So nothing to operate. You just provide your build script and it runs it for you. Same way, we have a tool called Cloud Deploy, which does the same thing with deployments, where you provide the artifact container image, and it takes care of deploying that artifact for you, right? So two awesome tools, two serverless build tool and a deploy tool. Anybody here uses Anthos by any chance? All right, just two. And Carlos doesn't count, he's from Google. So if you haven't used Anthos, the biggest selling point for Anthos is managing multiple clusters. Over time, organizations end up, I remember my Nike days, where again, we ended up with something like 40, 50 Kubernetes clusters. Right? What Anthos does is, across all those clusters, it provides a way to do GitOps at scale, and you can treat all those different clusters as from a single control plane. You can manage it from a single control plane, right? That's what Anthos does. Two products to highlight within Anthos: config management, which allows GitOps at scale. You can define your policies in a central Git repository, and Anthos config management will take care of propagating those policies across your cluster. One simple example could be, say, if you need to run a daemon set, say a security daemon set across all your clusters, all you need to do is define it in that central repository, and it will be propagated out across your cluster. The second one is ASM, which is, if you have worked with Istio, think of it as a managed Istio. It provides a secure way for you to make service-to-service calls, traffic management, telemetry, out-of-the-box telemetry, right? If you call other services, you can see the view without needing to do anything at all. Right? So that is ASM. That covers the productivity aspect of the tools, which I wanted to show. The next one is efficiency. And here we have touched on it 1,000 times already, which is the best way to get efficiency is to use, as much as possible, the managed services that Google Cloud provides, or, if possible, fully managed services that Google Cloud provides. And there is a difference between managed and fully managed. We can touch on it. You just contact me later and I can go over it if required. The runtimes that we provide is Cloud Run, serverless container runtime, or GKE, Google's distribution of Kubernetes engine. And there are multiple versions of that. There is one where you keep your hands completely off the platform, and Google takes care of operating it for you. That's the GKE Autopilot. And there is a GKE standard version where you have to be a little more hands-on. And similarly, on the database side, we have a whole host of databases that are fully managed by Google, and they are literally planet scale, right? You can keep putting data, and the platform will scale out appropriately as required and be performant at the same time, right? So that is the managed runtimes and databases. We have talked about Google's commitment to open source ecosystem before. Again, probably why open source may be important to you. The first thing is the license costs. You don't have to pay any license costs to Google. But secondly, more important from a developer perspective, in my case, if there is a problem, say with one of the runtimes, I would love to go to the Git repository of that product and check out what that potential bug could be, right? That visibility you will never get with a closed source proprietary product, right? So that is a bigger buy for me, why sort of open source matters. Third point about efficiency, FinOps. FinOps is a hot topic nowadays, and FinOps is built into a bunch of Google products. Here, what you're seeing is an example within the Kubernetes engine where you are given visibility into your workloads and then recommendations on what you can do to improve the efficiency, right? You can maybe remove one node, or maybe you can size a node differently, right? All that recommendations is made within the platform itself, right? So that is the FinOps part of it. Finally, security. This is very important. And one tool that we released recently that may be of interest to all of you is something called the software supply chain security. What you're seeing is a typical build pipeline, something that takes in the source, builds it, pulls in the dependencies during the build, uses a deploy tool to run it in a runtime. It's a typical build pipeline. What you see in red are the many attack vectors that's possible in this pipeline. Somebody can inject in a bad code. Somebody can put in a bad dependency into, say, a upstream Maven repository, and it gets pulled into your pipeline. Right? Somebody can compromise the build system itself. Somebody can put in a bad build code, right? The build pipeline code. Right? So these are all the possible attack vectors. And the solution that Google Cloud provides, there are other solutions in the market also, but from a Google Cloud's perspective, we provide a tool called Software Delivery Shield. It is a fully managed end-to-end software supply chain security solution. It provides a comprehensive solution for all the attack vectors that you saw in the previous slide. Again, as an example, during development time, we talked about cloud workstations. That is an awesome tool where the server where the cloud workstations is running, you can be sure that it is upgraded and it has the right patches and everything else, right? So it's not even the development is happening on a machine which is fully patched. During supply side, when you're pulling in dependencies, we provide what is known as assured OSS packages, which is Maven dependencies or container images which are certified by Google, which are sort of constantly checked for vulnerabilities by Google. So when you are pulling it in, you can be sure that those are validated by Google and there are no known vulnerabilities within those. Then the CI/CD, during the build process, we also create, I'm not sure how many of you have heard of SLSA, SLSA. Oh, okay, Anwar has. SLSA stands for Supply Chain Level for Software Architects. It is software artifacts. It's a mouthful, I know that. But what it is once during the build process, when you create the artifact, it sort of puts some metadata on the artifact with information about what all went into the artifact, right? The BOM, the bill of materials about how the artifact got created. And it also signs it. And what that does is, if, say, the artifact is modified in any way, the signature will not match up, right? So you are guaranteed that nobody has compromised that artifact in any way. And then during runtime, it can make sure that, it can again make sure that whatever artifact it's running, it's created by the right build tool, and then only run it. Right? So that is the Software Delivery Shield. Again, a lot of it, if you are interested, we would love to sort of show you more. Right? This requires almost a couple of hours of even trying out to appreciate this product. All right, so I think that brings me to the summary, which is that if you are ready to start on this journey, understand your users. As platform engineering team, you have to understand the applications. Organized around the platform's desired state, you should have a product manager for the platform if you plan to go this journey. You should treat platform as a product. We have touched on it a few times. And most importantly, start. Start small, measure, iterate. If you can start collecting the DORA metrics that was referred earlier, you should do that and start on it. And that's all I have on the platforms.